All right, so this lesson should pretty much be a review of things that you already know, but it is important that you are able to both find a hypotenuse and find a leg of a problem, and then actually recognize what the problem is asking you to figure out. So what we're going to do is you're going to start in your Walch books. This is Walch 5.1. Actually, my book is in the other room, so I don't know what page it is, but I'm confident that you can find it. Find Unit 5, go to the first example where you see the lesson applying the Pythagorean theorem. So you can pause it if you need to find it, but we're going to go ahead and get started. So the first question tells you to find the length of the hypotenuse of a right triangle with legs measuring 8 inches and 5 inches. So you should always be drawing a picture. I'm going to make this a right triangle by indicating that this one is asking us to find the length of the hypotenuse. Well, I know the hypotenuse is always across from the right angle, so the value of C is right there. And I know that this particular right triangle has legs that measure 8 inches and 5 inches. So I'm going to end up doing a squared plus b squared is equal to c squared. And here we're looking for c. So 8 squared plus 5 squared is equal to c squared. So it's going to give us 64 plus 25 is equal to c squared. So at this point, when we combine 64 and 25, we end up with 89 is equal to c squared. But we want to take the square root of that, which is going to give us a c value of my calculator doesn't want to do things. Okay, give me 1 second. All right, so when we take the square root of 89, we end up getting 9, it says to the nearest tenth, so 9.43, so we end up with 9 4/10 as our value of c. All right, moving on to example 2. It says, given a right triangle with a hypotenuse of 13 centimeters. So across from the right angle, you've got 13 centimeters and a leg of 5 centimeters. Find the length of the third side. So here we're looking for one of our legs. So we can make this A, B, C, and x squared plus 5 squared is equal to 13 squared, since a squared plus b squared is equal to c squared. So x squared plus 25 is going to be equal to 169. I'm going to subtract 25 from each side, and I'm going to get that x squared is equal to 144. So now I take the square root of each side, which gives me an x value of 12. So here I know that if my hypotenuse is 13 and one of my legs is 5, that my other leg has to be 12 centimeters. All right, so continuing along here, all of these questions are going to be about the Pythagorean theorem. So it says Tim is building a triangular garden in the corner of his rectangular backyard. So he's got his backyard here, and then he's going to build his little corner garden here. So he will be using 12 feet and 15 feet of his back fence. So 12 feet of the back fence there, 15 feet of the back fence there. And it says, given the length of the sides of the garden, how many total feet of fencing will he use to create his garden? So here, I guess we're going to assume that he needs this and this in addition to this value here. So we need to figure out how much he needs for this piece here, as he's going to fence that piece in. So we know that we have a situation here where we need to find the hypotenuse. So we're going to do a squared plus b squared is equal to c squared. So that's going to be 15 squared plus 12 squared is equal to c squared. Well, 15 squared is 225, and 12 squared is 144, and that's going to be equal to c squared. So 225 plus 144 is equal to 369, and that is our value of c squared. So I'm going to do 369 divided by x to see if I have any perfect square factors there. And I am not seeing any. Yes, I am. I'm seeing 9. So I know that 9 times 41 is equal to 369. And then I just want to make sure 41 is a weird number. All right, so as we go through this, this is as simplified as that's going to get. So we end up having a situation where we have 3 root 41 is equal to c. So this value here is 3 root 41. So if it wants to know how many feet of fencing he's going to use in his garden, it's going to be 12 plus 15, which is going to be 27, plus 3 root 41 feet. And that would be your total amount of fencing there. All right, next question here says that you've got 2 children that are directly opposite each other along the shore of the lake. They form a right triangle with a lifeguard station located 20 yards horizontally from one child. If the lifeguard station is 70 yards from another child, how far away are the 2 children? So this is just asking us to find this distance right here. So as I go to solve that one, this is going to be asking us to find one of our legs here. So I'm going to do a squared plus b squared is equal to c squared. So that means that x squared plus 20 squared is going to be equal to 70 squared. So that's going to be x squared plus 400 is going to be equal to 4,900. So x squared, when I subtract, we're going to do 4,900 minus 400, and that's going to give us 4,500. So now we're going to go ahead, and this does say approximately, but let's go ahead and simplify that radical. So x squared is equal to, well, 4,500 is going to be 45 times 100. There's a perfect square, right? So we'd have x squared is equal to, well, 45 is 9 times 5. That's another perfect square times 100. So when we start pulling pieces out here, we can pull out a 3 and a 10. So x squared, or not x squared, just x, because we're taking the square root, is going to be equal to 10 times 3 times the square root of 5. So that's going to be 30 root 5. So you can go ahead and check that. You can do 30 root 5 in your calculator, and you can also take the square root of 4,500, and you will see that you get identical answers there, that is how far apart the children are in that image. All right, so next question here is going to get a little more complicated because we are dealing with a variable, but still not that bad. So it says that Kim and Terry are sitting on opposite corners of the pool. The pool is x by 2x feet, and she throws her goggles approximately 38 feet to reach Terry, and it wants to know what are the dimensions of the pool. So in this situation, 38, I know that this here is a right triangle. So 38 is a hypotenuse, and I've got legs of 2x and x. So I need to go, and it wants to know what are the dimensions. So I basically need to find x. so I can figure out what 2x is, and then I'll know the dimensions of the pool. So x could be my A, 2x could be my B, but what that's going to end up meaning here is that I've got my value of A, which is x squared, plus my value of B, which is 2x squared, and that is important, is going to equal my value of C, which is 38 squared. And again, the only reason I put that in parentheses is to see that, like, technically you're always putting it in parentheses, but putting a positive number inside parentheses to square it seems redundant. But here, x squared is going to be x squared. Well, here you have to square both parts of this. So 2 squared is 4. So this is x squared plus 4 x squared is going to be, does that make sense there? Because we have x squared here. This is going to give us 4, and then x squared is going to be x squared. And then 38 squared is going to give us 1,444. So at this point, I know that x squared plus 4x squared minus 1,444 is going to equal 0. So when I'm looking at this, this is simple factoring here. So they need to multiply together to give me negative 1,144, but add to give me positive 4. So I know that these are going to be digits that are close in value. So I'm going to go to my calculator. I'm going to do negative 1,144 divided by x. I'm going to go to my table. So I'm going to have to go toward numbers that are a little bit bigger because I would need the numbers to be relatively close in value again if they're going to add to give me positive 4. So as I go through these, okay, at 38 they're equal. So I'm going to start looking around there. I wonder what has occurred that is wrong here, because something must be wrong. All right, give me 1 second. All right, y'all. So welcome to the world in which I've been home by myself for so long that I've entirely lost my mind. So, as some of you are probably sitting here wondering why I was trying to factor this, because we have like terms here. Hello to my brain needing to be functional. So right here, when I combine these, I'm actually going to have 5x squared minus 1,444 is equal to 0. So here, technically, I'm going to need things that multiply together to give me 5 times that value, and that's simply not going to be feasible. So this is not a process that we are going to participate in. So we're going to try to solve this one using perfect squares. So we're going to move this back over to the other side. So we have 5x squared is equal to positive 1,444. Then we're going to divide by 5 here. So we're going to have that x squared is equal to 288 and 8/10. So now this is not going to be a perfect square, but we're going to take the square root here, and we are going to get that x is, when we take the square root of 288 and 8/10, we get that x is equal to 16.99 hundredths, so we're just going to make that about 17. So what that means here is that if the goggles, I think, went 38 feet apart, well, we got that x was 17 units here. And then we're going to go back and say here that 2x is going to be 2 times 17, so that's going to be 34, which means that we have a situation where if we want to know the dimensions of the pool is 17 feet by 34 feet. All right, so that is really it when it comes to the lesson here. So it's a pretty quick one if you know how to add, which apparently I don't. So sorry about that there. Hopefully you caught it before I did. But as you're looking at those, that's just applying the Pythagorean theorem. So your homework tonight is in your Walch book. So the first thing is going to be the problem-based task for this, which is, hold on, let me get my book. All right, so it's going to start with the problem-based task on page 191. I highly recommend that you draw a picture because it is really similar to example 5. That ratio of a 4:3 ratio can be expressed as side lengths of 3x and 4x. So hopefully that helps as you try to solve that problem there. Then the second part of your homework is just going to be to continue onto page 192, and you're going to do the 10 problems that are on 192, 193. So those are just 10 problems related to the Pythagorean theorem. Again, I highly recommend that you draw a picture so that you are able to see the triangle and really know whether or not you're dealing with a hypotenuse or a leg. But other than that, you are ready to go do your work for today. And then tomorrow we are going to look at special right triangles. So we're going to start trig later on this week, but special right triangles are triangles that have specific angle lengths where you don't use trig relationships because there are just specific rules about the side lengths that are even more simple. So trig also is going to deal with right triangles, which is why it brought us back to the Pythagorean theorem before we start this unit. So hopefully this was a pretty easy review day for you, but please do get this done. All right, I'll see you guys later. Bye.